Okay, let's quickly go over what we have done last time. John's parents recorded his height at various age between 36 and 66 months old, okay? Now, when people give us a data set, to understand the data set, we begin with what? Graph. And this graph is called what? Scatter plot, okay? From the scatter plot, we find there is a strong linear relationship between age and height. And we also given the 5-number summary, okay? Now, let's denote the regression line as y hat equal to a plus bx. Now, from the new topic, we're going to change the notation a little bit. We call this is beta naught hat plus beta 1 hat x. Put a hat here means beta 1 hat is used to estimate the regression slope, the true regression line slope, beta 1, okay? And this is regression slope. And this is used to estimate what? Y-intercept. Okay? And what we have learned before the midterm exam, we can use the formula. Slope is correlation coefficient times standard deviation y over standard deviation x. And that is I is 0.998 times standard deviation y, 4.32, divided by standard deviation x, 11.54. And this gives what? 0.3738, okay? And beta naught hat is A, is y-intercept. How we get it? The formula is average y minus slope times average x. So this gives 20.46, okay? Now this operation, in the final exam, I probably give you what? The R printouts, okay? And you need to be able to read it. R printouts. Let's flip to the next page. Coefficients. Intercept, age is what? The variable, the independent variable, okay? So y hat equal to beta naught hat plus beta 1 hat x. We can quote it directly from what? From the table, okay? This is beta naught hat, this is intercept, 20.1 for about 46 plus 0.3738 x, okay, roughly. Okay, and then we use what? RStudio, okay? We put what? The variable, the information of the data, okay? 36 months old, 48, 54, 60, and 60, 66 into age, and height follow the same way, okay? Plot, age is what? X, height is Y, and main is the place you put your name for the scatter plot, okay? And COR is correlation. You want to find the correlation coefficient between X and Y. And LM, you put the question mark, you can use what? Tail function to understand the detail of linear model, okay? So this is linear model, height against age, okay? And information, going to put what? Mod, and you summarize mod, okay? Okay, this is what? This is from correlation of what? age, and height. And you get this number is 0.9978297, okay? And after you put summary mod, this is the printouts, okay? And how are you going to interpret the printouts? Okay, let's do it one by one. First one, let's look at this. Residual, okay, residual. This is E1, E2, E3, E4, and E5. What is E? E means what? The prediction error. Okay, so E1 means Y1 minus Y1 hat. Okay, E1 means Y1 minus Y1 hat. So what do you know about E1 squared plus E2 squared plus E3 squared plus E4 squared plus E5 squared? This is called what? This is called SSE. Okay, this is called SSE. So look at here. E1 squared plus E2 squared plus E3 squared plus E4 squared plus E5 squared. You square these 5 numbers. Add it up. That give you what? SSE. Okay, that give you SSE. And SSE, if you compute it, okay, you're going to get this number is 0.324329. Okay, roughly, not exactly. Okay. Now, what is MSE? MSE is SSE divided by the degree of freedom of SSE. SSE is 0.324329 divided by degree of freedom of SSE. Last time I mentioned this is what? Sample size minus 2, okay? For simple linear regression model, okay, you lost 1 degree of freedom in estimating what? Beta naught. You lost another degree of freedom in estimating beta 1, okay? So you lost 2 degrees of freedom. And data size is 5. 5 minus 2 is 3. So this number divided by 3, you should get 0.10811, okay? We're going to come back to this table shortly, okay? Now, a linear probabilistic model. Definition: the simple linear regression model. There are parameters, beta naught, beta 1, and sigma squared, such that for any fixed value of independent variable x, the dependent variable is a random variable related to x through the model equation. Y equal to beta naught plus beta 1 x plus epsilon, okay? The quantity epsilon in the model equation is a random variable assumed to be normally distributed with mean equal to 0, variance equal to sigma squared, okay? So this is what? Unknown. And how are we going to estimate the size of the sigma? It is estimated by what? Okay, it's estimated by MSE, the one we just find in our example. Okay, it's estimated by this. Are you with me? So some people just call this one is what? It's called sigma square head. Okay. Inferences about the slope parameter beta 1. Okay, it can be shown that beta 1 hat follow normal distribution with what? Its mean. Expected value of beta 1 hat is exactly equal to beta 1. The true population what? Slope, regression slope. And this one is variance of beta 1 hat. Okay? Now, in the real life application, sigma square is unknown to us. Okay? So we're going to use what? We're going to use MSE to estimate sigma square. So people call this is what? Sigma square hat. Okay? And look at here. Beta 1 hat is normally distributed. And its mean, expected value of beta 1 hat, and this one is beta 1. Okay? So this is a picture, normally distributed with center equal to what? Beta 1. Okay? Now, we're going to give you a concrete example later. Okay? To demonstrate how this procedure actually works. With beta 1 hat, follow normal distribution, center is what? Beta 1. Okay? Then we can talk about hypothesis testing or confidence interval for beta 1. Now, I'm going to do confidence interval later. Let's work with what? Hypothesis testing first. Okay? For that, please flip to the next page. Hypothesis testing on model utility test, okay, is beta 1 equal to 0 against beta 1 not equal to 0. Look at here. Y equal to beta 1 x plus beta 0. If this is equal to 0, what does that mean? Huh? There is no linear relationship between y and x. Is that clear? So this is called model utility test, okay? So how can we do the test? This is step 1. Okay, step 1. And step 2. No linear relationships. Step 1 says no linear relationship between what? X and Y. Okay, that's what they say in what? In H0. Okay? HA always say what? This is not true. Step 2, we choose alpha equal to 5%. Okay? Step 3, test statistic used. We use beta 1 hat to estimate beta 1. And remember what's beta 1 hat? This is R times standard deviation Y over standard deviation X, or equivalently. This is summation Xi minus X bar squared. This is summation Xi minus X bar, Y minus Y bar, okay? Test statistic use beta 1 hat. We use beta 1 hat to estimate beta 1, okay? And our decision is we're going to reject H0. if p-value less than R5 to 5%. Okay? Okay, in step 4, we compute p-value. And the definition of p-value is under the assumption that H0 is true, how likely test statistic behaves at least as extreme as the observed value. Okay? So let's see. This is the beta 1 hat. We know beta 1 hat follow normal distribution. And its center is expected value of beta 1 hat. And this is beta 1. And what do you know about beta 1? Well, under H0 is true. Beta 1 is 0. Okay? No linear relationship. No linear relationship between x and y. Okay? Beta 1 equal to 0. This is what we expect to see. But what we observe is 0.3738, okay? It's not equal to 0, okay? Under H0 is true. What we observe, this is what we expect. And this is what we actually observe. Under H0 is true, what we observe should be close to what we expect. If what we observe is not close to what we expect, further deviate from the expectation is called extreme, okay? But because our HA is two-sided, so either too big or too small is considered extreme. So how we compute the p-value? This is 2 times probability. Test statistic beta 1 hat. And observed value of beta 1 hat is what? 0.3738, okay? Or even bigger, okay? Under the assumption that beta 1 is what? Equal to 0, okay? So this is a p-value, okay? This is a p-value. This shady area times 2. And how can we find the shady area times 2? Okay, we standardize beta 1 by subtract the mean divided by standard deviation. But sigma squared, as I mentioned before, we use MSE, okay, to estimate. And this is what? Summation xi minus x bar squared. After we plug in the number, okay, and the numerator is 0.3738, and we're going to get what? The t ratio, 26.24154, okay? This is a computed t value. So the p value become what? P value become 2 times probability that t with 3 degrees of freedom greater or equal to 26.24154, okay? That's a detailed computation procedure, okay? You want a copy? Go ahead.